I'd like to welcome you to the 5th video in my series for Chapter 6. And as promised at the end of the last video, today we're going to use our calculator. And we're actually going to use MoLand over there. And the first step before we get into the chemistry though is to make sure you know how to use your exponent key. And of course, life is difficult. Everybody's calculator is a bit different. I have a Texas Instruments calculator here. It's actually not my favorite. It's got extra steps in the functions that you have to go through. Most of you might have a Sharp or a Casio calculator or something that's more in that line. It actually works more easily. So let's just type in Avogadro's number. If you have your calculator, you're also going to need your periodic table, and hopefully you have a picture of MoLand from a previous lesson. I've left it up here as well in an abbreviated form so we can look at that. So let's type in Avogadro's number. Well, in my case, with my Texas Instruments, I'm going to type in 6.02, second function, which is in the top left corner. Then I've got to find the key that says EE. And if I do that correctly, I've got a little E beside my 6.02. And then I can type in 23. So that's how I would get Avogadro's number. Do not use the 10 to the X key because it'll actually get you off by a factor of 10. And that doesn't work. The Sharp calculator, if you have it, or the Casio, actually easier. You're going to type in 6.02 EXP, which should probably be in the top left corner of your calculator, and then 23. Again, don't type in EXP times 10 to the 23 because that'll give you a number that's to the exponent 24, making it 10 times too large. So, if you have difficulty with all that, feel free to get in touch with me. Assuming that's all good to go, let's do some chemistry. So like I said, today we're going to look at section 6.5 in the book, and we're going to become really good at figuring out grams from moles, moles from grams, which you've already done in the last lesson. But we're also going to venture into the right side of this MoLand, figuring out atoms and molecules. If molecules pertain to covalent compounds, I'll probably use the terminology formula units. Don't worry about that. That's the same as a molecule, but it applies to ionic compounds. So when you see formula units in your text, just think molecules, even though formula units apply to ionic compounds and molecules pertain to covalent ones. All right, let's look at the aluminum that I gave you before. So you may remember that in a previous video, I gave you 13.5 grams of aluminum. And we were able to figure out how many moles that would be using our triangle. The question now is, can we figure out how many atoms there are? And the answer is yes. So the first thing we'll do is figure out how many aluminum atoms are present in 13.5 grams of aluminum. That's our question. Well, if you look at MoLand over here, we're actually starting at mass land. We have mass, and we're going to go here first. I know we've done this previously, but just to reinforce it, let's go through it. So our first step is mass to mole. So what do we know? Well, we know a couple things. We know the mass is 13.5 grams, and we know from our table that the molar mass of aluminum is 27 grams per mole. I'm rounding that up from 26.98 to make life simple. If you want to be more accurate, that's fine. Nothing wrong with that. So let's figure out our moles. Of course, using our triangle here, moles equals grams divided by molar mass. So if we plug that in, we have 13.5 grams divided by 27 grams per mole. Notice that the grams cancel. We have to watch our units. Remember, the units are your friend, not your enemy. So we have a nice round number, and our answer is half a mole of aluminum. So what have we achieved? So far we've gone from grams to moles. Now we have to go from moles to particles, or in this case, atoms. This is where we're going to use our table. Simply enough, the number of aluminum atoms in this question is equal to 0.5 moles times 6.02 times 10 to the 23rd atoms per mole. Okay? So we can cancel out our moles. And I know if you look at this, you can see that half of Avogadro's number should be easy to get without a calculator. Of course, we know that half of 6.02 is 3.01. So we can just simply do it. The answer will be 3.01 times 10 to the 23rd atoms. Now, you don't want to trust short chemists, so use your calculator. Try to go through it like I showed you to verify that answer. But this will be our answer for the atoms of aluminum. And that's allowed us to go from mass land over here through mole land and to atoms. Because we know the mole sharks will not allow us to go from grams to atoms directly. So that's our first example. Let's look at another one. The next example I want to take a look at is a molecule. So we're going to go back to water because water is a compound, and while compounds get treated like elements a little bit, I also want to take a look at the difference between atoms and molecules. So simply enough, let's suppose that I gave you let's say we want to find out how many grams of water are present in 1.20 times 10 to the 24 molecules. This is our question. How many grams of water would be present in 1.2 times 10 to the 24th molecules of water? So you'll notice I'm actually making you go the other way. I'm making you go from here in particle land back to mole land and then ultimately to mass land. Let's go through it. Well, we know a couple things. The molar mass of water, of course, I've gone through it a number of times. This will be a number you'll probably memorize, to be honest, 18. And we know that the number of molecules is given, roughly 1.2 times 10 to the 24th. So, first step, we're going to be able to find moles first. We're going to start here at particle land and move to mole land. So therefore, the number of moles in this case is equal to 1.2 times 10 to the 24th molecules. But notice that we're going to be dividing because we're going from particle land back to mole land. So we're going to divide by 6.02 times 10 to the 23rd molecules, which is good old Avogadro number. That is per mole. And, like before, units are your friend. Let's cancel out molecules. I'm going to round this off to make life easy for myself and for you. So 1.2 times 10 to the 24th divided by 6.02 times 10 to the 23rd is very close, excuse me, to 2.0 moles of water. Now, 2 moles of water doesn't make a lot of sense to a chemist. If I say to you, go get me 2 moles of water, you're going to wonder how much that is. That's why we're going to go to grams. Our final step involves using the mole triangle. And we've already been there. So in this case, grams is equal to moles times molar mass. And this is the easy part really because we've already done this. So we have 2.0 moles, and we know that water has a molar mass of 18. And look at that. We get 36 grams of good old water, municipal draft, whatever you call it, and that would be about 36 mils. And look at that. Just by process of luck, I have 36 mils of water in this little cylinder here. So you can see it's not a lot of water. But that, my friends, is how we can calculate mass from molecules. We've got to be able to go both ways with it. It's a little bit tricky. Our next step is to make sure we understand the difference between atoms and molecules, and we can use water as an example. That'll be the next video, video 6. Hopefully this helped. Again, look at section 6.5. Try some of the problems. I'll take a few of them up in the near future. It's not the easiest stuff. Get good at using your calculator. Till next time, we'll see you around.